Jai Hind everyone, I am Anuradha Dhumale from Computer Science and Engineering Department of Akgec Engineering College. Today our subject is blockchain architecture design and our topic is blockchain technology. That means the introduction of blockchain technology. First of all, to know the blockchain technology, we should know that the different types of network, that is the in a network there are a centralized system, decentralized system and the decentralized system. We are using for the blockchain, the decentralized network is used for the blockchain technology. Now the centralized system. Centralized systems are a type of computing architecture where all or most of the processing of data storage is done on a single central server or a group of closely connected server. It means in a centralized system, there is only one server is there and that one server is accessing all the transactions, verifying all the transactions. That central server have the authority to control the transactions. This central server manages all operations. Limited scalability, as the central server can become a bottleneck if the load increases significantly. Adding more clients can strain the server's resources, leading to performance degradation. We can see that this is the centralized system in which this is the server, the main server which is handling all the operations related to these nodes. Okay, if the one node is failure here, the all over the system is failure. Second is decentralized system. Now in a decentralized system, all the nodes are located particularly at the different locations and all that nodes handle or access the transactions by itself. Decentralized systems are computing architectures where multiple nodes, often spread across different locations, share control and processing power without a single central authority. There is no single central authority. Each node in a decentralized system operates independently but collaborates with other to achieve a common goal. Okay, here the nodes are differently working differently, but their goals is common. They achieve the common goal for particular transaction. This structure enhances fault tolerance, scalability and resilience compared to the centralized system. In a decentralized system, if one node is failed, then there is another node which handles the situation, which is give approval to the transactions for the network. Distributed control. No single point of control or failure is here. Each node operates independently. Contributing to the overall system's functionality. All the functionality is handled by the other node if the single node is failed here. Fault tolerance. If one node fails, the system can continue to function with the remaining nodes. Function resilience against failure and attacks. Blockchain and cryptocurrency. Decentralized ledgers. Ledgers are nothing but the record which keeps the record. Ledger is like the digital notebook in which all the updates, all the transactions updates are recorded there. Decentralized ledger that records transactions across multiple nodes without a central authority. There is no central authority for this ledger. Everyone have the records, everyone have the ledger. In decentralized network, the transparency is there. All the updations are visible to every nodes. Benefit: enhanced security, transparency, resistance to fraud and censorship. Okay, examples of these decentralized networks are Bitcoin and Ethereum. These are the mainly usable cryptocurrencies here, that is the Bitcoin and Ethereum. Distributed system. In a distributed systems, all the networks are located in a different location, okay, but they are having the common goal and working as a single system. Okay, they don't have authority, they can't take the personal, they can't take the actions, or they don't have the authority, individual authority to control the access, to control the transactions over the network. The control is shareable here. Distributed systems are computing architectures where multiple independent nodes or computer works together to achieve a common goal. These nodes communicate and coordinate with each other over the network, appearing as a single coherent system end user. Okay, distributed system aims to improve performance, reliability, scalability, and resource sharing by leveraging the collective power of interconnected device. Geographical distribution of distributed network is nodes are spread across different physical location. Okay, nodes are spread across different physical location. They communicate via networks such as local area network. There is a LAN connection is there, and local area network connection is there. Concurrency, multiple nodes operate concurrently, performing tasks simultaneously. There are multiple nodes located at the different locations. They are operates concurrently, but the performing task simultaneously. There is a sharing access is there. This parallelism enhances the system's overall performance and throughput. Resource sharing, nodes share resources such as processing power, storage, and data. This enables efficient utilizations of resources. Now, this is the a difference between the centralized system, decentralized systems, and the distributed system. The definition, first we will see through this aspect. The definition of the centralized system is single central server control and manage all operations. Centralized system. In centralized system, there is a single central server who control and manage all the operations. In decentralized system, multiple nodes with independent control and no central authority is there. Multiple nodes. Okay, there are multiple nodes which are located at the different positions, and they don't have any central authority to access the transaction. Distributed system, multiple interconnected nodes working together as a single system. Multiple interconnected nodes working together as a single system. Multiple nodes are there, but they are working as a whole system, as a single system. Now, in the aspects of control, centralized control with a single point of management. In centralized system, there is a single control. Okay. In decentralized system, there is a distributed control. Each node operates independently, and each node have the control. Each node have the authority to access or to verify the transactions. Distributed system, there is a shared control, design or fault tolerance to design for fault tolerance and redundancy. Okay, there is a share control. Single point of failure, the centralized system is having the high risk. If the central server fails, the whole system fails. There is a high risk of failure because the central authority is there, and if the central authority is failed, then the whole system is failed. In decentralized system, it reduces the risk because failure of one does not affect the entire system. If one node is failed, then the other nodes are available to tackle up that transactions. Reduce risk, design for it reduces the risk. It designs for fault tolerance and redundancy. Now, in the aspect of scalability, the centralized system has the limited scalability, can become a bottleneck. There is a limited limited nodes can join the network. In decentralized network, it is more scalable and everyone can join the nodes, everyone can join the network, can add nodes independently. It is highly scalable, can add more nodes to distribute the load. If the if the more nodes are available, it is highly scalable. Okay, if the more nodes are available, then the load is distributed to the other nodes. The resource utilization, central server resources are heavily utilized here. Resources are heavily utilized in centralized system. In decentralized system, resources are spread across multiple nodes, and in distributed system, efficient resource sharing across nodes. Performance, in the aspects of performance, in centralized systems, it can be high initially but may degrade with increasing load. If the load is increased, in that case, the performance is degrade. If the load is increased, if the nodes is increased, the performance is degrade in the centralized system. Performance is degrade. But it is in the centralized system, we can see that the generally good performance improve with more nodes. If the nodes are added to the network, the performance will be good there. In the distributed system, high performance due to parallel processing and resource sharing. There is a parallel processing is happening in the distributed system. There is the performance is high. In the case of management, easier to manage centrally. There is only one server is there, so that it can easy to manage centrally. Decentralized system more complex, requires managing multiple nodes. It requires multiple nodes to manage, and it is complex than the centralized system. In the case of distributed system, complex, required coordination and management of many nodes. In this distributed system, there are distributed nodes are there, but they are having the parallel processing system, so that the coordination is necessary in this case. In the case of latency, the centralized system is having the lower latency as operations are managed centrally. The response time is slow is here, can vary depend. In distributed decentralized system, the latency can vary, depends on the distance between the nodes. They are located on the different locations, so the latency is vary, and it's depend on the distance between the nodes. In the distributed system, a potentially higher latency due to the network communication. It is having the higher latency. So, this is the difference between the centralized system, decentralized system and the distributed system. Now, come to the blockchain. What is the blockchain? As the name suggests, blockchain, it is the chain of different block which stores the data, which stores the informations, which like we can say that we use the database for storing of data, but here blockchain, we store the data in the form of block. So, start with the introduction to blockchain. A blockchain is a type of data structure where data or information is stored in a blocks of chain. Okay, all the information, all the data is stored in the form of block. Each block contains some information with hash value of previous block. Now, every block contains the information, but what that block exactly contains? The block contains the header value, the block contains the transaction, the block contains the nonce value, the block contains the hash value and also the hash value of the previous block, so that they can form the chain with that previous block value, hash value. The hash is unique mathematical code which shows the specific block in the blockchain. Always remember that the hash value is the unique code. Blockchain ensures the transparency, security as well as the decentralization. Blockchain is basically based on the decentralized network, so that the transparency is there. Security always, if the more nodes are available, the network is more secure. A blockchain is one type of digital ledger of transaction where each transaction is duplicated and distributed across the entire network of computer system. Each Blockchain is a one type of ledger. Ledger is a nothing but the digital notebook. Ledger is nothing but the records which stores the information, which stores the transactions, what is happening in the network, all the updations, all the data, all the transactions, updations are stored in the ledger. As each block contains the number of transactions and any new transactions occur on a blockchain, then it is known to every other participant ledger. If any transaction comes to the network, then that transaction is known to every ledger, every participant. This block of chain is managed by multiple participants. Okay. With the help of decentralized database, this technology referred as a distributed ledger technology. As we know that we using here the decentralized network, so the transaction, all the transactions happening in the network will be known to the every participant to the ledger. So this is called the distributed ledger technology. The blockchain technology is used in digital cryptocurrency. Basically, the main application, main use case of the blockchain technology is the cryptocurrency, like the Bitcoin, Ethereum. We are buying the digital money, digital currency online. So the Bitcoin will be more usable, or the application of the blockchain technology. Now, what is the blockchain? See, here we can see that there are different blocks which is forming a chain. When the new transactions come to the network, it stores in the form of a block, and that block is added to the previous blockchain. Blockchain is a system of storing and transferring information in a distributed and decentralized way. Storing of information in distributed and decentralized way. We can think of it is ledger or a record book that is shared and updated by many participants instead of being controlled by a single authority. There is no single authority to control this blockchain. There is no single authority to access this blockchain. Every nodes, every participants available in the network will handle, will access, will verify this blockchain. Okay, this is the advantage of this blockchain. Now we can see that there is a different blocks attached in the blockchain, but what exactly that block contain? Okay, so in a single block, we store the header value, previous block address, previous hash value address, timestamp, nonce value. Nonce value is nothing but the number ones value which is generated by the miners, and this is the Merkle root. Merkle root is having the root is having all the type of transactions which is happening there. So here this is the structure of the blockchain. Every block contain the different data. In a single block, we can see that header value, hash of the block header, okay, okay, the previous hash value of the block. This is the timestamp and nonce which is generated by the miners. Miners are nothing but the participants who can solve the puzzles. The puzzle is very complicated puzzle given to the miners. They solve the puzzles and generate the number, that is the number ones, which is equal to the hash value, and after that, that number is stored. They get rewards for this, that is in the form of Bitcoin. Now this is the hash of block n-1. Okay, the hash value of this block. This is the hash value of the previous block, and this is the hash value of this particular block. This is the Merkle root. Merkle root is nothing but the Merkle tree which is having the different transactions. That transaction is combined and forming a one root. That root value, this is the root value, is stored in the Merkle root, which is giving the all the information about the transactions, what type of transactions are happening there. So why blockchain is trustable? The blockchain is trustable on various reasons. It is an open source. Okay, this is the open source in nature, that why it is used in business application. This is the open source. Anyone can join the network, anyone can access the network, so that it is used in the business applications. It is compatible in business application. It is used in online transactions because of high security. In a blockchain network, there is a high security, so that we can use in online transaction for the banking sector, for the finance sector also. In business, the developer always pay for the security. The business does not matter in any situation. The blockchain is considered easily. Benefits of blockchain technology. The process is faster and cheaper because no central authority for verification. Okay, the process is faster. Individual node is accessing the transactions, give the suggestions and gives the approval. So the process is fast. There are no expenses added in the blockchain technology. There is no expenses added. It gives tighter security over blockchain, where no other person can modify the data. We can say that this is the blockchain is immutable. If once the record is updated, then that record is not changeable, that record is not erasable. That means it is immutable. No one can change or no one can modify the data. The blockchain enhance or the security. The blockchain enhance the security. Security is the major advantage of the blockchain. After that, the blockchain provides the greatest transparency, where blockchain provides the distributed ledger. Distributed ledgers is updated at every node. Distributed ledger is every node in the blockchain network having the ledger, which is updated every time when the transaction is happening in the network. Okay, so blockchain creates audit trail, which documents the provenance of an asset at every stop on its journey. The blockchain increases the efficiency and speed of the transaction. Each entry transactions in the ledger is verified and encrypted by a network computers called nodes using cryptography. There is a transactions which is encrypt in the form of encryptions. Okay, for these transactions we have to know that the public key and the private key. To decrypt that message, we know the public key of the sender, and receiver used his private key for the decryption of the message. These transactions are grouped into blocks, and each block is linked to the previous one by the unique code called the hash. Okay, these transactions are grouped into blocks, and each block is linked into the previous one. The transactions is in the form of block, and each block is linked to the one another. That is, this creates a chain of blocks. This creates the chain of blocks, or a blockchain that is secure, transparent and immutable. See, this is the blocks which is forming the chain, and this is having the hash value. This is the hash value of the particular this block 1Z at F, and this is the hash value of the second block. But this particular block is having also the previous hash value, previous block hash value, that is 0000, and this is the second hash value of the block 1. Previous hash value of the block 1 which stores in the block 2 also. So, with the help of this previous hash value, we can form the chain, that is the blockchain. There are three generations for the blockchains: first generation, second generations, and the third generation. In the now we can see that how did blockchain technology evolve. Blockchain technology has its roots in the 1970s, when a computer scientist named Ralph Markle patent hash trees or marker trees. In 1970, it is founded by the Ralph Markle. These trees are a computer science structure for storing data by linking blocks using cryptography. Cryptography is used for linking the blocks to one another. In the late 1990s, Todd Haber and Scott Stornetta used Merkle trees to implement a system in which document timestamp could not be tampered with. This was the first instance in the history of blockchain. The technology has continued to evolve over these three generations. The first generation, in 2008, an anonymous individuals or a group of individuals known only by the name Satoshi Nakamoto outlined blockchain technology in the modern form. Satoshi Nakamoto outlined the blockchain. Satoshi's idea of the Bitcoin blockchain used 1 MB blocks of information for Bitcoin transactions. He used only the 1 MB blocks. The size of the blocks was 1 MB. Many of the features of Bitcoin blockchain system remain central to blockchain technology even today. The second transaction blockchain 2 is having the smart contracts era. Few years after first generation currency emerged, developer begins to consider blockchain applications beyond cryptocurrency. Blockchain has outgrown its original functionality of powering cryptocurrencies with blockchain to a smart contract era. In generation 2, we are using the smart contracts. In third generations, we are using the Ethereum with the help of smart contract. The third generation decentralized has more advantage than centralized app like improved privacy, complete data integrity and zero downtime, and it's attentive to areas like speed, security and scalability, interoperability and environment friendliness. Okay, thank you.